It's amazing the things I've done with duct tape.
You're listening to the Cosmic Cast.
Good morning, afternoon or evening. Today we have me, Marissa Lowe, Elliot Carter, Dr. John Pernay Fisher, and straight off of Stromboli, Benjamin Esse.
Hello.
How's it going?
Oh, it's going pretty well.
So you are a PhD student here, and you're in your... What year are you in?
Fourth year.
Fourth year, wow.
Yeah,
So, okay.
Slightly terrifying.
Have you said
Very
fourth
good.
year yet?
I have uttered
okay.
it under a blanket.
I had to say second year the other day and it felt very strange.
Yeah, it's a bit terrifying.
Yeah. So what is it that you do, Ben?
So I am a volcanologist. Specifically, I'm a remote sensor. So I like to use instruments to measure volcanic plumes from very far away. So I don't have to get up close and personal with a volcano, which is generally well advised, I feel. Predominantly I use UV spectrometers or cameras. So that's using sort of scattered sunlight around in the atmosphere. Yeah.
So that's pretty cool. So you're basically like on a boat somewhere with like some sort of spectrometer.
I have been on a boat with a spectrometer, but it was only the one time. Usually we do it from the ground,
Okay.
or from a car or something. But actually, saying that, I've done it from the ground, car, once in a helicopter, which was great fun,
nice.
and one time on a boat, but the boat unfortunately didn't work.
So you've been mostly working in Italy then?
Yeah, so I've been around the world a little bit, but most of our work has been in Italy, on Stromboli, which is a small island volcano off to the north of Sicily. Yeah. It's a really nice place to go and visit if you're on holiday.
Yes,
so
I'll
it's
bet
a
it is.
better place to go and do fieldwork.
And so in fact you've just come back from Stromboli just a few weeks ago, haven't you?
Yeah,
I
we were
think?
out there for about a week and a half
Yeah.
in September.
Measuring more gas.
Yeah, well, we were there actually to measure the gas and ash in the plume. So Stromboli is this really nice volcano. A lot of people call it a laboratory volcano because it tends to erupt every 15-20 minutes. Just a small, what's called a Strombolian eruption, which isn't very big, but they generally kick out a bit of ash and a bit of gas. So we're there to measure some instruments that we're designing and developing for measuring ash plumes.
So what are you hoping to understand by measuring the ash and all the gases and all that kind of stuff?
There's two things really. One was to look at the dynamics of plumes. So a lot of people maybe listen to this will remember in 2010 there's a big eruption of the volcano in Iceland.
Now we're going to ask you to pronounce that.
I knew that was coming. It's something along the lines of, and I'm going to apologise for any Icelandics listening, Eyjafjallajökull.
That sounds
Yeah,
pretty
yeah.
good.
I've practiced and am still rubbish. So that erupted in 2010
Yes.
and had a big, they submitted this large ash plume all over Europe and caused a lot of disruption to the airlines. And a lot of people were stuck on holiday. Boo-hoo people. And one of the big things about that eruption is it wasn't that we were, I don't know, what's the best way to put it? Yeah, one of the worst impacts of that eruption was basically we didn't know where the ash was in the atmosphere. We shut down all the airlines so they wouldn't have any chance of running into the ash.
Yeah, I remember that. I was living actually quite near Heathrow at the time, and I just remember noting that how clear all the skies were, and just
Nice
the
and quiet.
noise of it was amazing. It's because I guess it's the sort of thing you sort of drown out in your consciousness, isn't it? All planes going overhead all the time, but
That's true.
its absence, it was definitely palpable, and the sky was so clear where you haven't got all those trails, so for once the chemtrailing, the chemtrailing and the government-sponsored poisoning.
I suddenly had control over my own actions again.
Yeah, exactly. Yeah, the fog lifted from my brain, and I was able to see clearly. Yeah, but sorry.
So
Thanks,
yeah,
John.
4 minutes in and we're already completely off track.
one of the biggest problems is that we just didn't know where the ash has gone.
Right.
And so a lot of improvements since then have been made in modelling the dispersal of ash. But one of the biggest unknowns is still how you go from the actual eruption column, so when it's actually coming out of the volcano, and then actually how it spreads in the atmosphere. So the linking between those isn't too well known.
And so it's controlled by the gases that are present and
It's
chemistry.
just a really complicated problem because it depends on how strong the eruption is. You have what's called weak or strong plumes, which are, a weak plume is where it's really bent over because the wind's blowing it sideways. A strong plume is where it's sort of more buoyantly just rising straight upwards in an eruption column. And so you have a bit of an interplay with the local atmospheric conditions and the actual eruption conditions. and how those play out can have a big role in how the ash plume will be dispersed. So we're pretty good now at, once the ash is in the atmosphere and we can figure out where it's going to go, but linking the actual eruption itself to the rest can be quite difficult. So that's what we're trying to do with one of the jobs with this. This
so you've been focusing on Stromboli then because it's quite a sort of a simple system, or?
Well, it's an easy volcano to use for measuring ash because reliably it's going to kick out a little ash explosion about every 15 or 20 minutes.
Yeah, okay.
Otherwise you have to wait for a volcano to erupt and then sort of peg it towards it, which isn't always the most wise thing to do.
So can you then scale that up then to apply to other volcanoes?
Yeah, we've been looking at doing similar things on Etna, which is a volcano in Sicily.
Yeah.
Again, a very nice place to go.
Yeah.
And we also actually did measurements when we went out to Central America, to a volcanic dome complex called Santiguito, which is in the eruption scar of a really big volcano called Santa Maria in Guatemala.
Okay,
wow.
That's really cool. So I guess how does that link to, and this is really it's dragging up some of the volcanology I learned in undergrad. So you've got different types of volcanism, so Strombolian and Plinian and all that kind of stuff. How does that link? So if you've been studying a Strombolian type volcano, can you apply it to other types of eruption? Is that?
Yeah, I suppose it's just a scaling thing, like you say. Strombolian is more on the lower end. So you have what is called a volcanic explosivity index, which goes from 0 to 8.
Right.
I think. Well, 0 is Hawaiian eruption, which is basically no ash, it's just the lava flow coming out. And 8, I think, is called megaplinian or something like that,
okay.
Which is your super eruption style things, which we've
where
only seen.
ash will travel, continents.
Yeah, well, around the globe several times usually, I think.
Right. Okay. Wow.
So it'd be like a Pinatubo or something like that.
Yeah, Pinatubo, I think, was a 6.
Okay.
Off the top of my head. At 8, I think we're looking more at like Tambora.
Yeah.
It was an 8, and I think some of the past eruptions at Yellowstone might have been.
Okay.
Yeah.
So is Tambora the year without a summer?
Yeah.
Yeah.
When was? I've not heard of that.
1812.
Yeah, I think so.
Yeah.
Okay.
I was like 18 something.
Or maybe
It's
14.
like the global temperature dropped by 2 degrees or something.
Where is
Yeah.
Tambora?
Indonesia.
Indonesia.
And Mary Shelley writes Frankenstein. There's a whole sort of thing about the weather was so bad that she went on holiday to Switzerland, I think, and they couldn't go outside. And maybe because she was stuck inside because it was raining.
Yeah.
That's why she wrote Frankenstein.
Wow.
That's a pop trivia.
You do get more global effects with even smaller eruptions. So like Krakatoa, it was I'm not sure what it was. Was it a 5? I might have to look that one up.
Head, but I don't know.
Yeah, we'll go with 5. If it's not, I'm sorry. And that caused funky sunsets around the world for a while afterwards from all the aerosols that kicked out. Sort of like when you have a really dusty sky and it gives you that lovely red colour. Same thing happens. I heard that's what inspired the background in the Scream, the painting. But I can't remember whether that's an urban myth or not. I think it's true.
Well, on this podcast, we won't be bothering to check any facts, so that's fine.
No fact checking here. I can say whatever I want.
Yeah. So
cool.
what does a typical ash plume look like on Stromboli?
Dark. Well, actually, darkness. No, it was one thing we noted whilst we were there. So, as a little side note, I've been to Stromboli 6 times, and this is the first time we've been when it's been really nice weather.
Oh.
Really? That's surprising.
Believe it or not, it's rained pretty much every other time.
What sort of time of year have you been going?
Like April, June,
Okay.
October, September. We've been at all times of year, and we just always got really bad weather. So this was a really nice trip where we actually had beautiful clear skies, no cloud on top of the volcano.
Oh.
So we got a really good look at where the explosions were coming from. And there's a few vents at the top. So the actual summit area is formed of a number of different craters, which have a number of different vents inside. It's not all coming out the same hole, as it were. And there's quite a distinct personality between the different vents, which is quite cool. So what we think was coming from the northeast crater is called this. There's a northeast, central, and southwest, which are I think the main ones. The northeast had this really sort of dark, ashy plume. The central one was more gas, and then the southwest was more like a light, ashy plume. So you really saw a good variety of activity even on the same volcano.
So when you're at a volcano, is your aim to test your measuring of ash and so on, or is it to actually study how the dynamics are in that particular place?
Yeah, so far a lot of my work has been on instrument development. So we've been there to test how well we can see the ash with our cameras, and we've done that a few times now, so now we're beginning to move on to more of the looking at what we can see with the cameras. So far it's been more of a testing and development, and now we're moving more into actually using them for some interesting stuff. For example, there's another set of cameras that look at sulfur dioxide. It's called an SO2 camera. So sulfur dioxide is one of the big gases that volcanoes emit. I think it's the third most abundant after water and carbon dioxide. But sulfur dioxide isn't really around in the background atmosphere, so it's a lot easier to measure than water and carbon dioxide, which are. By measuring the sulfur that comes out, you can quite easily get an idea of how much gas is coming out of the volcano, and that's very useful for monitoring. But one of the problems is when you have these ashy plumes like we see on Stromboli, that ash blots out the signal from the SO2. And so what we were trying to do is use the ash camera to try and basically identify where the SO2 camera would be having issues, so that we can sort of tell it where not to look, basically.
Right, okay, so you're sort of using these together.
Yeah,
right,
as a combined tool.
Okay. And these just off the shelf cameras that you buy, or
sort of? They're actually astronomical cameras, so they just need to be sensitive to the UV, which normal cameras aren't, because they have what's called a biofilter on. Which is I don't know what it does. I don't know enough about cameras, unfortunately, but I know it stops UV light.
Right.
Okay, so I'm guessing it's just like they have different filters inside them.
Yeah, so most cameras have got that. I think it's the RGB filter.
Oh, okay.
Right.
I think that's where this comes from.
Is it probably to stop the sun frying your camera?
I think so. I don't think UV light's usually what you want in, but for astronomical cameras, apparently, it's fine. So we tend to use those.
That's cool.
So is the kind of thing you're working on things that could then be scaled to satellites and stuff to look at an entire huge plume? Like, because originally you're talking about Iceland, say.
Yeah.
Is this something you can then use to track that ash, or is
Yeah,
it more
probably.
of a ground-based thing?
At the moment, it's more of a ground-based thing, but I think the nice thing about remote sensing is, as long as your light source is the same. I mean, our light source is the sun, so you can still see the sun from a satellite. And there are UV satellites up there looking down at volcanic plumes that measure the sulfur dioxide and also sometimes the ash. So I don't see why this couldn't be scaled up.
So what's been your favourite volcano that you visited?
Oh, that's an excellent question. There's so many. Stromboli will always have a special place in my heart because it was the first one I went to, the first active volcano I saw. And I remember the first time I saw an eruption there, I had that sort of, oh wow moment.
Ben, I've never seen a volcanic eruption.
We need to get you as a field assistant on one.
Yes, please. I've only been to a couple of volcanoes. I've been to like Teide, I've been to Etna.
That's not so bad.
Yeah, but I've not seen them erupting. And I feel like now that I do moon volcanoes, I'm not going to for a little while unless I'm there by chance. So, what are the eruptions like?
It depends how close you are.
Yeah?
From far away, really pretty, really awe-inspiring, and you can see the real energy that's involved in these things. Up close, scary. We've had a few times where we've been on top of the volcano and the weather's pulled in, visibility drops, and you can hear an explosion go off in the background. This sort of full-on.
Oh God!
It sounds like a jet engine roar,
Wow.
and you think, right, there's something that's throwing red-hot glowing rocks into the air, not too far away from me, and that's a pretty real feeling.
Presumably you've got special permits to approach.
Yes,
and all that kind of stuff.
So a lot of volcanoes are rightly so covered by various health and safety rules. So we tend to go up either with trained guides or with members of. For Stromboli, we do a lot of work with the INGV, which is the government institution that looks after the volcanoes. So we know what we're doing, and we're not expecting anything.
Yeah. How
go
close
wrong,
have you
but-
gotten to actual lava?
Actual lava. I've never actually seen a lava flow, which is something I'd like to see. I have seen a lava lake, though. So we did some work at Masaya volcano in Nicaragua, and that was pretty cool. So that's one of the few volcanoes on the planet that has an active lava lake. You could see it sort of
Bubbling away.
bubbling over and rolling.
Wow.
Yeah.
What
It's
sort of
very
size
cool.
is the lake?
I think it's about like 20 meters. No, 10 meters across.
So does it just look like a big boiling bath of lava?
But to be honest, it looks just gassy most of the time.
Right,
So all the
okay.
gases they condense quite quickly, so it can be quite hard to see the actual the lake itself. But when that clears, it just looks like a red, glowing, churning mass of stuff.
Wow.
It's the best way I can describe it.
That's cool.
How close
very
could you
cool.
get to it? Like, could you feel the heat from it?
No, so that Messiah's got a bit of a double crater. You can stand on the very crater edge, but then there's another crater floor inside, and then in that there's another smaller crater, which is where the lava lake is.
Ah, okay.
so you can't get too close, and it's
Yeah.
quite far down. It's maybe like 100 meters away.
Yeah.
So not close enough to feel the heat.
Yeah.
But you can see the glow on the clouds at night from quite far away, which is quite cool.
Wow. Have you ever felt like tremors or earthquakes during these eruptions?
Not
Or-
during an eruption. We once had an earthquake when we were in Catania, which is one of the cities near Etna, and it was just in the night. I think it was a magnitude 5, and we did feel we felt this earthquake, which originated from underneath Etna.
Wow. Okay.
I say felt. I woke up, vaguely noticed it was moving, and then fell back asleep. I didn't really clock it until the morning.
You probably just thought, I've just had a bit of a weird dream.
Yeah, I just have a vague memory of being rocked, and then I was back asleep.
Okay. Yeah, I've never experienced an earthquake. I remember going to Iceland a few years ago, and they had an earthquake machine. So you could pay it was the equivalent of a couple of quid, and you just stood in like a
Yeah.
little pod, sort of like a shower shape
They
size.
just sort of shook you up a bit.
Yeah,
those
and
things
the
are
floor just sort of
rubbish.
shook, and yeah.
Well, they
it
had
was,
something like that in the Natural History Museum. I don't know if they still do.
yeah,
I
it was
saw
quite
that as a
fun.
kid. I never
Yeah.
went when I went.
It was rubbish. It's just like a
Oh.
board that just moves from side to side, and you get jiggled about a bit.
Oh, at least the one
know.
I went in, they like flashed the lights.
Oh,
Sort of
really?
had like sound effects to it, so
Right.
it was quite entertaining. Yeah, but I imagine a real one would be.
A bit different.
So Ben, you've not always been in the world of volcanology or geology.
No.
I believe you did your degree in physics.
Yes, I know nothing about rocks, and this is much to the amusement of my fellow PhD students sometimes.
Yeah?
I started out life. I did my undergraduate in physics with astrophysics at
Here
the
in
University-
Manchester?
No, at the University of York. Actually.
Okay.
And loved that. I always wanted to study heliophysics, so looking at the sun. So I did all of the plasma physics options I could. And then about 6 months before the end of my masters, I thought, I want to go outside. Basically. So I thought, how can I use my physics degree and my love of like climbing mountains? And I was looking for different PhD projects, and this one popped up where I could go to a volcano and measure it. And so the idea of being paid to travel to volcanoes appealed.
Yeah.
And so here I am. I haven't looked back since.
Yeah.
But it's actually really cool. Although I do miss out a little bit, and I found it a bit confusing at times, not having the sort of the basic knowledge about geology. Bringing in a different perspective on things, I think sometimes is quite useful.
Yeah,
so just have a
absolutely.
slightly different mindset to just in the way I think in the way the undergraduate training went for physics as opposed to geology. We're sort of taught slightly different things. So bringing that in as a bit of a curveball to everyone else's thinking, I think sometimes is quite useful. You get a bit of perspective on things.
Yeah, that's good. Yeah, you'll definitely know lots of things that we won't know. And you've
Like
obviously
maths.
picked up loads of things.
Yeah.
Like maths, coding, useful things like that.
Yeah, I mean, most of the coding I've learnt has been just self-taught during my PhD. We had a very little introduction.
Well, I think that's what PhDs are about. You know, you don't have to be in
No.
that field necessarily. You just learn a
Yeah.
lot during your PhD.
Yeah.
So
And I've learnt a lot about rocks.
Yeah.
So much. More than I ever thought I would want to.
So was this the specific project that you saw that you wanted to go for, or did you apply to a whole bunch of different projects?
I did apply to a bunch of different ones. I applied for another one, which was at Leeds, which was to fly a drone through a volcanic plume, which I really liked the sound of, and then thought, that drone's going to crash. Because volcanic plumes aren't nice. You know, ash isn't good. There's reasons planes don't like flying through them. So actively trying to fly a drone through one didn't seem like a good idea, or a good way to have a lot of funding left over at the
Well,
end.
so if you're on that PhD, dear listeners, good luck with that.
Yeah, I actually know someone who is. So there we go. I had a few. I applied for one in glaciology, which was completely different, and another one which was building a spectrometer to fly on a satellite for measuring methane.
okay.
But again, that would have just been 4 years sat inside
Yeah.
an optics lab.
Yeah.
Didn't fancy that.
Yeah. Yeah, I mean, I guess that's it's what brings a lot of people to geology is the outdoors element. It's,
Yeah, I think it's a really big draw and a really big advantage of it. And the skills you learn doing fieldwork is it's completely different to anything else you can do, because that little bit of responsibility and trip planning and just dealing with things when you're out there in the field. It's a lovely feeling when you're on this island. You haven't really got any phone signal. You don't have to worry about emails or paperwork or any sort of admin stuff.
Yeah.
Yeah.
All you have to do is figure out why your spectrometer isn't working and how you can use duct tape to stick it to a wall or something. It's,
Yeah.
a lot of volcanology fieldwork is duct tape as well. It's amazing the things I've done with duct tape.
So speaking of flying things through volcanic ash, you've been on a helicopter and flown through a plume?
Yes, not an ash plume, thankfully.
Yeah?
So this is some work we've done out in Montserrat, which is an island in the Caribbean.
Ah, yeah.
I love all these names. You're just name dropping, Ben.
I know. Dropping on the names of the nice places I've been in.
So Montserrat, so that no one lives there anymore, is that right?
No. So it's still got a population,
Okay.
much diminished. So
It was the capital,
Plymouth.
that
was destroyed.
So when was that eruption? I've got
1994, and sort of
okay.
ongoing since then.
Yeah.
So for those of you who don't know, Montserrat is a small island in the Caribbean. It's about the size of Dublin. I've learned that over the years. And the bottom half of the island is dominated by this volcano called Soufriere Hills.
Mm-hmm.
And in 1994 it erupted and have sort of destroyed the bottom third of the island or so. So that is now, and still is, covered in an exclusion zone where you're not allowed to go,
Mm-hmm.
which includes the capital city, which was pretty much buried by pyroclastic flows, and but also a lot of areas around which weren't necessarily destroyed but are just too dangerous for people to go back. And it's actually a really sad situation there because this includes a lot of people's homes.
Yeah, sure.
And there's but unfortunately at the moment it's, the volcano is still active. It's still showing signs of, it's got this constantly degassing plume. So from a safety point of view, it's just not viable to let people.
So
go
that's
back.
quite incredible. Then it's been erupting for over 20 years, I guess.
Yeah, I mean a lot of volcanoes do this. They have this sort of constant passive degassing where they're just kicking out gas all the time. So this Soufriere Hills isn't erupting, as in it's not throwing ash, and it's not producing lava flows. In fact, there's a bit of discussion in the volcanology group as to what exactly is the situation is going on there. And this is where we looked for things like the past history of how much gas it's been putting out, how many volcanic earthquakes there have been, how much the volcano itself is actually deforming, and by looking at those patterns we can try and get an understanding of what's going on. But it's all trying to look at something that's buried several hundred meters underground, so it's not very easy.
It's not the case of just, this volcano hasn't erupted in 50 years, therefore it's safe to live next to it.
Right, yeah. I mean, we say historically active volcanoes for the last, I don't know how many, it's like thousands of years. But volcanoes that have been basically quiet or unresponsive for 10,000 years could suddenly just up and start erupting again. These things are geological timescales, so they don't
work on the
100-year timescales. No.
And presumably across the globe there must be loads of communities that are next to these potential similar situations.
Yeah, I think it's about 200 million people live within 15 kilometers of a historically active volcano.
Yeah,
something like that. It might be 50 kilometers, the exact number. But it's a lot of people, and so it's a big worry for local governments and risk managers, because situations can change. Yeah. Suddenly, you can have a lot of people in a very dangerous situation. Yeah. And even just trying to get people to evacuate.
Yeah,
is very difficult.
I mean, I guess some people are very stubborn and they don't want to move, do they?
Yeah. There was actually a really interesting study recently, which was looking at the number of deaths from a volcano, and it found that most of the deaths aren't typically from the first eruption. So typically we see that eruption coming, we tell everyone to get out from the exclusion. I say we, the royal we here. I don't do any of this, but local risk managers can see the signs. They get people out of there. Maybe the volcano erupts safely. We know if everyone's away. Sometimes the volcano doesn't erupt. An example of that is, I think, Guadeloupe. There was a lot of unrest there. I can't remember the exact date of it, but then nothing really happened. So sometimes we get it wrong. But what tends to happen is when you tell everyone to go away, they go away, and then they start thinking, well, when can I go home? It's a similar situation as in Montserrat. It's these people's livelihoods, especially if you come from a poorer area. Yeah. If you're a subsistence farmer, you've had to leave your farm behind. Yeah. And so what do you do?
Yeah, I mean, it must be devastating. I mean, I can't even imagine what that situation must be like, really.
Yeah. So a lot of these people go back, even when it's not necessarily safe, and then if the volcano erupts again, then that's when a lot of the deaths occur. Yeah.
That's cool.
Sorry to bring the tone down. Volcanology is very depressing,
isn't it? I feel bad asking you about the helicopter, because I know you weren't very well in the helicopter.
Oh, the helicopter. Yes, no, yeah.
That's how we got into this. I was like, so you were in a helicopter at some point.
We sort of vaguely tangent away from that, didn't we?
So what did you study while you were at Soufriere Hills?
So we were there to sort of get them, or to help them out with doing their gas flux measurements. So this is some measurements we do with UV spectrometers, where we basically in some way drive a spectrometer underneath the plume, and what we do is to sort of measure a transect of that plume.
And this is within the exclusion zone.
Yeah. Because that's typically where the plume gets. Sometimes it does go to the north in that area.
Did you get to go through lots of abandoned villages and all that kind of stuff? It must be quite creepy.
Yeah, it was scary. Like, and this only happened like 20 years ago.
Yeah.
And you've got these like old rusted shells of buildings. But so yeah, we did a few by car, and luckily enough, we did a few by helicopter as well. So, and that was both flying under the plume to get this sort of flux measurement, but also we were flying through the plume to measure the gas composition. So typically when we're doing flux measurements, we just look at sulfur dioxide. But when we're flying through, we're looking at other gases as well, so like water, hydrogen chloride, carbon dioxide.
So is this like quite a thick plume of gas? Like, do you have to wear a gas mask, or is it pretty diffuse by the time you...
Moderately diffuse where we were, although we did kind of fly up the plume towards the volcano and got butt-clenchingly close to the to the dome itself, which was an experience. Kudos to the helicopter pilot; he was one brave person. Yeah, but it did get a little bit coffee at times. But with the helicopter, we're going in and out of the plume so quickly, we didn't need a gas mask.
Right.
It's only if you're spending sort of a significant amount of time, or if it's, like you say, if it's significantly concentrated. But by the time it's in the atmosphere, it tends to get diluted fairly quickly.
Okay.
Cool. So is that the last of your field work for your PhD done now?
Who knows?
Are you basically, are you on call? If there's going to be another big eruption somewhere in the world, will Mike just say, right, let's go?
Yeah, it kind of feels that way sometimes. That's bad, I shouldn't say that. No, sorry.
I know some of your trips have been quite last minute, haven't they?
Yeah, we have had a tendency to book things, or to plan stuff last minute, when we just need to go out and go. But that's just the nature of a volcano. If the volcano's doing what you need it to do, then you need to get out there.
So you're not necessarily done in the field yet.
No,
that's cool.
Might have one more trip left over. I only got 6 months till after funding my thesis. It's fine. Who needs more data?
Me.
I can give you some if you want. I don't know how useful it'll be.
I'll take whatever's going.
Also, your laptop never breaks because it gets filled with ash, was it?
Yeah, well, it's been a bit everything. I feel like I should send a commendation to Lenovo for these laptops, but like, it's survived everything.
Yeah.
I should say it did recently have to be slightly tended back to life. But no, it's been ashed. It's been volcanic gas, which is like quite a dense acid plume.
Yeah.
I'm still trying to scrub the smell of that plume out of my clothes, and the laptop's fine. Well, it's had a tree in it at one point, and sand. Yeah. But only just recently, so I decided that it had enough.
Yeah.
It's had a bit of a clean, and it seems to be all right again. So
that's great news.
Well done, laptop. I'd be very sad if I had to retire it.
Yeah.
It's been through a lot, bless it.
I'm sure IT services have been very impressed.
Their look when they said, "Here's my laptop, it's not turning on." Why? It's been volcanoed. It's like, what? I don't think these are necessarily designed for field work. But.
Yeah. Well, time is running out, unfortunately, but we've got one last question for you. This is for regular listeners. This is the usual question we like to spring on people at the end of an episode. And we're always very curious to know, if you didn't choose to go down this path of volcano exploring and then gas measuring and all that, what else do you think you might have done? What else interests you outside the world of your PhD project?
Oh, I think... Well, if I remained in academia anyway, I think I would have gone down the aisle of plasma physics. Mm-hmm. Really enjoyed that and learning about that in my undergrad. And just learning about the sun, so looking at heliophysics. The sun's a really cool thing. It's kind of the centre of our solar system, literally. You guys need to know that.
Subscribe to the heliocentric model.
Geocentric.
Flat Earth. Two conspiracy theories enough.
If we listen back to this and it turns out you've just been whispering like flat Earth in the whole time.
There's life on Mars.
Jet fuel can't melt steel.
But yes, plasma physics, there we go. And if not that, I don't know what I'd do. Something in the mountains, probably.
Yeah.
I just love being outside.
That's cool. So you do a lot of climbing or mountain climbing? Or?
Yeah, when I can. I was actually supposed to be up in Scotland this weekend climbing some Munros, but unfortunately I've pulled my calf, so I couldn't go.
Instead,
so I'm
you're
here
here with us instead.
Although looking at the weather forecast, I think I'm slightly glad. I just dodged a slight bullet there.
Yeah.
Brilliant. Well, if you do pop back off to the field anytime soon, you'll have to come back on and tell us what you were doing.
Definitely.
But in the meantime, it's been a fascinating conversation. Good luck with writing everything up. And, well, thank you very much.
Thank you for having me. Cheers.
Thanks, Ben. Bye.
Cheers.